Hey, you all good people. My name is Nambura Kiba. Welcome to my YouTube channel. I will be taking you through mathematics. That is, if you're in campus and you're majoring in applied mathematics, I will be taking you through majorly the applied units, applied mathematics units. And I'm not a lecturer. Yeah, I am not a lecturer. I'm only a student. I'm in my third year, second semester. And I'm not taking you through these units because I know a lot, I'm taking you through this unit so that we can learn together. And I hope we all learn, Yes, I am not basically teaching, I also want to learn from whatever it is that we will be doing together. So I hope someone will be helped out there. I hope someone will love to learn mathematics through these tutorials. They will be short tutorials, but I really hope that somebody will be helped mathematically, and that also me, I will be helped in some type of way, that my grades will not remain the same, because mathematics is not as easy as probably our parents think. Najua wazazi wetu wanatuambianga, mimi nikiwa kama wewe nilikuwa nafanya hesabu kama si pesa ilinizuia, like it's not as simple as they try to make it look like. Yeah, mathematics is tough. The point is, mathematics is not simple, but I'm glad because we are tougher and we are in this together, Manze. We will conquer, and we are here to try and simplify mathematics. So if you happen to come across probably a sum that I will not do the way it's not supposed to be done, just know that I'm not a mathematics expert. I'm just trying to upgrade my expertise in this field of mathematics, and probably, or specifically, the applied mathematics field. So without wasting so much time, we can see that this is a blank book, and today I want us to learn some complex analysis. We will start with complex analysis 1, just to build, the basis of the entire complex analysis course. And from the course description, we will basically learn we will not have so many things to learn in complex analysis 1. The major things that we will learn in complex analysis 1 is majorly 1, the complex plane, just to introduce us to the complex analysis course. 2, we will learn limit, continuity, and differentiability of complex functions. 3, we will learn the analytic and elementary functions. 4, we will learn about the Cauchy-Riemann equations. And where were we? Is it 5 or 4? I've crammed these things, so probably when I forget, don't hesitate to correct me. 5, we will be learning about the mappings, I think, by mappings by elementary functions. And 6, we will be learning about complex integration, Cauchy's integral theorem, Taylor series, Lorentz series, singularities, residuals, Cauchy residuals theorem, Cauchy-Gaussian theorem, and poles. Yeah, but don't worry about the description. We will be learning step by step I won't take you first, Please don't also take me first. We're learning, and in this course we will really have to refer to our Calc Class 1 and 2, especially Calc Class 2. Yes, so if you've lost your notes on Calc Class 2, it's your time to find them now, since we will have so much to relate in this unit. As I've told you, I will be taking you slowly through this course outline. We will learn the six major descriptions or 6 major subtopics in this complex analysis one, and me taking you through, I'm your what did we used to call them in high school? Co-teacher, peer teacher. Yeah, I'm your peer lecturer. Nyambura Kibe. I hope we learn, Manze. I hope we learn. So, as I have said, we will start. I don't know if I have a different pen, because so that I can highlight. I have a right one. Don't worry, my pens have no. Yeah. So, as I have told you, we will start on the complex plane. Yeah. It's not that hard, because you see, a complex plane is just a pair of real numbers. It's just a pair of real numbers. And in this course, we will use a lot of symbols, and mathematics is symbols and punctuations. We will use so many of these symbols, so don't worry if I use a lot of abbreviations. We may not have a lot of time to write the whole thing, but if you're here, I believe you're a mathematician, and that's why you checked in, So I am sure you will get to understand these symbols. They will not be so complex. So a complex plane is basically a pair of real numbers, and it is basically denoted as Z is equals to A plus BI. Yes, that is how the complex plane is denoted. Yes. And in this case, as we have said in definition, a complex plane is a pair of real numbers. So Z is the complex plane, Z, or you can say Z. So in this case, A and B are our real numbers. So representing a complex plane diagrammatically, in a diagram, yeah, it's represented in this way. This is X, the X-axis. In the X-axis, is called, as we all know, it's called the real axis. And the Y-axis, on the other hand, is called the imaginary axis. So, in this complex plane, we have a point here. We have a point AB, and this point AB can be represented as A plus BI, and in this case, the X-axis is the A. We have a distance from the X-axis we have another distance in the Y-axis that is equal to the distance A, and we call it the distance B, so that we have a point AB, which can be interpreted as A is equals to B plus I. And in this case, we will also define I. I is defined as negative root negative 1. the root of -1. And I squared therefore will be -1. I hope we are clear up to that point. I hope we are together up to that point. Yes. And we have said this A is called the real part of Z. Let me just write for you down. Or, we bright students, if you're doing mathematics then, and you are in this year, probably you are doing this unit on your third year, you probably, I'm trying to imagine that you have done a lot of mathematics. And mathematics really opens up the brain. It's not a joke. Yeah. So, but let me just write for you that A is the real part of Z, and B is the imaginary part of Z. And in this case, I believe Z is the complex plane, isn't it? Yeah, I want to believe so. So, we can look at the properties of a complex number. Properties of a complex number And the first property that we will look at is equality. And please pay attention to this. In equality, we will say if Z1 is equals to X1 plus IY, and Z2 is equals to X2 plus IY, let's name this Y1 and this Y2. So if Z1 is equals to X1 plus I1 and Z2 is equals to X2 plus IY2, then Z1 is equals to Z2 if X1 is equals to X2 and Y1 is equals to Y2. I hope you're together up to that point. We have said that the first property of I'm sorry, my hand is shaking and I'm holding my phone using my hand, so forgive me. I really shake when I'm doing such work, but it's okay. I hope you understand. So we have said that the first property of a complex number is equality. And in equality, we have said the first part that we can prove this is the first proving the equality property of a complex number. We have said we have given ourselves two guesses. Guess one is when Z1 is equals to X1 plus IY1 and Z2 is equals to X2 plus IY2. Then we have said that then Z1 is equals to Z2 if X1 is equals to X2 and Y1 is equals to Y2. Please pay attention. You really need this in future for future reference. And two, if now in the second case, to prove or to define the equality property of a complex number, we say that if Z is equals to x plus I1, and y is equals to x, then I hope you can see my handwriting. It's not one of the best, but I hope you can really see what we are writing. So we have said that if z is equals to x plus iy and y is equals to x, then x is a member of the real, which did we say is the real part of z? The real part of z is a, isn't it? And it's also a member of the complex number, and complex is denoted as, we write a C and we write another small c like that. So don't start wondering what I've started writing here. Yes. I hope we're together up to there. And now the third one and the last one, but it will not be the final one. If x is equals to 0, z is equals to iy, then if x is equals to 0, then this is a pure imaginary number. Then I hope you understand. Forgive me if I don't explain better, but I'll try as much as possible to explain to us the best way that we can understand this unit. So we have said that if x is equals to 0, then xy is a pure imaginary number. Yes.